Hello, everyone. Good morning. I am Lisa Marie Namphy. I am the OpenStack ambassador for the United States and also run the OpenStack user group in the San Francisco Bay Area. And I am super excited to be joined by a couple of my esteemed colleagues from the OpenStack ecosystem to do, we haven't done this in our meetup for a while, an online meetup in webinar fashion. So first of all, really big thanks to Trilio for sponsoring this for us and to Brian and Billy for spending the time with us this morning. And I want to also give a special shout out to those of you from the San Francisco Bay Area user group, but also all of you in our user group that aren't in the San Francisco Bay Area and can't join us monthly or every other week when we do our meetups here. So super happy to come at you online. I'm going to start out by just giving you guys a kind of an overview of what we've just released in the Pike release of OpenStack, and then I'll hand it off to Brian and Billy after that. So for the Pike release, if we can advance the slides, can we advance the slides? Caitlin, can I get your help advancing the slides, please? Okay, I'm only seeing the title slide still. All right, there we go. Perfect. Okay, so as you know, Pike is the 16th release of OpenStack. It went out on August 30th, and this is actually really cool. This is the first cycle that we had where we kicked it off at the PTG meetings. So the first PTG meeting was in February in Atlanta. The second one just happened a couple weeks ago in Denver. I hope some of you guys were able to make it to one of those. And the Queen cycle was actually kicked off at the first ever forum in Boston during the summit, and we're doing another one in Sydney. So I hope you guys can join and participate in these. And the point I'm making is that the work that we've done in the community to loop operators and developers closer together is really starting to pay off, and you can really see that in this Pike release. So some of the bigger themes for this release were around the adoption of edge computing and the resurgence of private cloud, and we've had the numbers in the recent user survey really reflect that. But we also saw a big momentum in public cloud. This surprises a lot of people, particularly in the United States. There's more than 25 OpenStack public cloud providers in 60 availability zones, and there's an ongoing interoperability effort towards making it easier to move workloads among those public clouds. So a lot of really good work that was done there. Technically, some of the key takeaways were, every release has hundreds of features that go into it, but these three here are kind of the three big themes of this release. User experience and manageability. The community continues to focus on this. This has always been a thing, but we've continued in Pike especially, specifically like with lifecycle management of the OpenStack control plane. So in the early days, people were working on the install and getting the clouds up and running. But as you know, cloud is a living, breathing thing, and it has to run at scale and heal itself and continue to operate over time. So we've got 7 years now of lessons learned from running OpenStack clouds. And those lessons have been making their way back into the upstream community, and now there's a lot of work in different projects around lifecycle management. So what you do from day one across the number of years that you're running the OpenStack environment, we're taking all of that into account. And one of the more popular updates is the COLA project, which uses containers to run the OpenStack control plane. There's also OpenStack Helm, and this is a new project. It's not official yet, and that also leverages Kubernetes or other orchestration systems to manage those OpenStack services in order to have faster setup times, but also the ability to do more controlled upgrades and to automate the fault resolution. So if an API service falls down, Helm or the Kubernetes environment can restart that and get the cloud up and running again. So that's super cool. Flexibility and scale is all about scaling OpenStack production environments that have been around for years and they're getting larger and larger, and the guys are going to talk about this more later, I'm sure, because this is kind of their sweet spot. But this is essential for these large environments and customers to be able to continue to grow their businesses and to run those critical workloads. And then composability and modularity. there was a lot of demos in Boston about this, and particularly like on the main stage keynotes. Composable infrastructure gives you the ability to take the OpenStack services and piece them together and deliver the functionality that your applications need and create something really powerful for your environment. Especially for this release in particular, the work that was done around Ironic and Cinder with the services standalone to integrating Cinder volumes directly to Ironic without any usage of Nova, and Ironic and Neutron to have tighter integration of the network functionality with multi-tenancy. So this enables those use cases that we've actually seen a lot of people experimenting with, and a lot of those are now going into production. So those are the big themes of this release. I'll dive into a couple of key technical features that I think are very important to point out that may not be on your radar. So Python this is an interesting one. Yeah, if you could, oh, I got it, I see, okay. So Python is, support for Python 3.5. This is really important because, as you guys I'm sure aware, Python 2 is the version that's been running for over a decade, and specifically Python 2.7 for the last 4 years, that's what OpenStack has been standardizing on. And these versions are being end-of-lifed by most of the Linux distros and many other platforms that are running OpenStack. So there's some pretty big differences between Python 2 and 3, and there's even more big differences between 3 and 3.5. And so this is a heavy lift, and the community is working super hard to stay ahead of this, to make sure that the OpenStack services are fully supported in the coming version of Python, to make sure that we don't have a ton of technical debt to fix when in fact this actually does happen. So this really gives everyone the time to do these upgrades on their own schedule and in a way that isn't disruptive to their business. So here's another area where we're really taking care of our users now and well into the future. So just wanted you guys to be aware of that. The next thing, thank you, is Cinder. A lot of work was done by the Cinder team. I just really got to give them a shout out. One of the cool things is you can take snapshots in Cinder, but now you can actually move your volumes back and forth within the snapshot. So you can quickly take a VM back to a known good state, and it's kind of like a time machine, if you think about it in that way. So time machine for your virtual servers that are back-ended by Cinder. So if you have data corruption and you need to go back to a known good state, or if you have a test environment that you want to reset to a clean state, this is where this will really help you. With this release, it's really simple to do those kind of things. And this is going to continue to improve across all the Cinder drivers by the Queen's release. So the team's continuing to work on that, but they've got it started. For the next, another much requested feature for Cinder that we included in Pike is the ability to extend the size of a volume. So you can attach a Cinder volume to a VM. It looks like a hard drive inside that VM, and what you can now do is increase the size of that virtual hard drive without shutting down the virtual machine or interrupting the operation of that server. So this was a much requested feature, and we got it supported up through Nova and the projects that depend on Cinder. So very cool and good job for Pike. For Ironic, the Ironic team has rolled out rolling upgrade support. Can I have the next slide, please? Thank you. Rolling upgrade support, and most of the core services have had this, but now Ironic also enables operators to update the underlying control plane for Ironic without having to restart the Ironic services or incur any downtime on the fleet of bare metal servers that are running your business workloads. So this was a great update for manageability and for ongoing maintenance of the cloud. Okay, next. Actually, sorry, I just went to that one after. So one of the super cool, this is probably my favorite slide on here, because there's been a ton of work done in to grow OpenStack and to embrace adjacent technologies. And if you guys came to the summit in Boston, you would have seen this on main stage and also on the various tracks throughout the summit, and you'll see this again in Sydney. This is so important, a hugely important element that's driving OpenStack growth and adoption. This cross-community continuous integration. There's actually a name for it. I think the Linux Foundation calls it XCI. So you might see others using that term as well. But it's cross-community continuous continuous integration. And here you can see the logos of just a diverse group of open source projects that the community, the OpenStack community is working really closely with. And I can attest to that because in the meetup that we run for our user group, we've featured at least 4 of these, and we featured Kubernetes about 10 times since last summer, since last year. So we really are embracing these adjacent technologies, and this collaborative effort is driving innovation faster than any one community could ever achieve alone. So just to name a few, OpenContrail is another good community member, and we've done meetups with them as well. So good work. If you belong to any of these communities and you want to be part of the OpenStack user groups as well, please just ping me and we'll get you scheduled to come and show all of your goodness off to the OpenStack community. Okay, I'm going to stop there. I think the next slide is just how you can find us in case you're looking for us. There's a lot of ways to stay connected, but I'm going to hand this over to Brian Garrett of ESG, which is a leading industry analyst firm. And Brian founded the ESG Lab practice, which performs testing and analysis of data center technology products. Brian is a renowned expert in the enterprise storage and infrastructure markets, and he's got more than a decade of experience. So I hope you guys queue up some really good questions for him by the end of his talk. And then after that, we'll hand this off to Billy Field. Billy's the Director of Cloud Architecture for Trilio Data, which helps customers with data protection, business continuity, and migration software, specifically for the OpenStack market. Billy started his career as a software engineer at ENC, so he understands customer issues from both the technical and the business side of things. So I'm super excited to share the stage with both of these experts in our field. And Brian, I will hand it off to you.
Well, thank you so much, Lisa, and hello, everyone, and glad you could join us today. We're going to be talking a little bit about some hands-on testing and validation that we've done of the Trilio Vault, data protection solution for OpenStack environments. Caitlin, can you move on? I'll give you a little background on who we are and what we do, and then we'll dive right into things. So I work with the Enterprise Strategy Group. We're an industry analyst firm. We cover enterprise-class IT technology. We've got a real strong heritage in data protection and in data storage. We've been covering, and I myself personally have more than 20 years of experience making data protection and storage technologies, and we've been validating solutions now for about 15 years. We've done about 800 projects. So we sit actually between the IT professionals like yourselves on the phone, the technology companies like Trilio Vault and the open source communities as well, and also the investment professionals and the media, trying to provide market research. We do surveys and demand-side market research, traditional analyst advisory services and analysis, but that top corner to the right, the validation, is the part of the business that I run where we do technical and economic validation. And today I'm pleased to be showing you technical validation of the of Trilio Vault. Next slide, please. So within the Enterprise Strategy Group, the ESG Lab, we do hands-on testing analysis, and we create ports like the one you can see a quick peek of the cover shot, cover page for the Trilio Vault. And our goal here is through hands-on testing and working with product experts like Billy, who you'll be hearing from later, to watch a product, see if it works as advertised, validate things like performance, usability, scalability. We'll be touching on those factors here. But most importantly, we try to make these be real easy so that to consume, so you can see what was tested, how it was tested, but most importantly, why this matters. We try to put a business lens on it, ideally backed by our demand-side research, trying to show that it solves problems that you're facing today. Next slide, please. So in the Trilio Vault, the areas that we focused on that I'll skim through quickly here, and you can take a look at the report offline later, are ease of deployment, manageability, performance, and scalability, obviously all in an OpenStack environment. Next slide, please. Let's jump in with ease of deployment. Well, actually, before we do that, we'll show a little bit of our demand-side market research. We do annual surveys on IT spending intentions, and in particular around data protection. And as you might expect here, cost, performance, and recoverability are on the top of the data protection challenges. And as you're probably not surprised to hear that annually at the CIO level, when we're asking anybody who's involved in IT purchasing decision making, data protection and recoverability usually ranks in the top 3. Sometimes it bounces around. Lately, it's been trading places with cyber, but it's always up there. It's a problem we've been, trying to solve for 30 years, and we'll continue to be solving it because the environments keep changing. Next slide, please. So to that point, what we're seeing in our latest annual survey, we're seeing that 96% of respondents plan on maintaining or increase their spending on data protection. So data protection isn't something you can just spend on and have it be done. It's something where there's continuous investment on. And the reason for it, Jason Buffington, who he's the lead analyst for us for data protection, a really, really great guy and a smart thought leader here. This is his, his saying is that when you modernize production, you need to also modernize protection. And we've seen this in the industry a bunch of times, and most recently with the adoption of virtual server technologies like VMware and others, we saw that we needed to rethink how we did data protection. If we took the traditional methods and dropped them in a virtual machine, they weren't optimized, and eventually the APIs within the hypervisor allowed data protection solutions to adapt to be better suited to them. And you saw companies like Veeam come along to be building custom solutions, purpose-built and integrated native into virtualized environments. We're seeing the exact same behavior happening here in the OpenStack, and Trilio Vault is kind of a lot like Veeam. They're very, very focused on trying to make the data protection in OpenStack environments be integrated and granular and recoverable and fast, as we're going to see. Next slide, please. One more, the ESG Lab validation. So now we're diving into a couple of highlights from the report. Next slide, please. We're going to start with deploying and configuring. So there's a couple of components to the Trilio Vault architecture. The data mover technology is installed as a native service on the Nova Compute nodes. There's a Trilio appliance VM. And then there's a plug-in to the OpenStack Horizon Management Interface on the OpenStack controller that uses Trilio Vault APIs to communicate. It's a quick picture of the kind of the wizard-driven. Just click here to download and install each of these components. And we did this working with the folks from Trilio Vault in a test bed, and it was less than 30 minutes and very, very straightforward to get this thing up and running. So easy to deploy and configure. So let's move on, and what we got is what we witnessed was modern web browsable, easy to use management interface for setting up policies and using disk-based snapshots to automate easy recoverability. And as you can see here, you can set things up by workload and by policy. You can set up policies for protection. So we're going to be using disk-based snapshots. You can set up kind of gold, silver, bronze, and have more frequent snapshots. And there's also integration with OpenStack replication technology so that you can be doing backups and getting those backups safe to a remote site for remote recoverability. Next slide, please. And most important, this is one of the things that's kind of missing usually early when we come into a new production environment that doesn't have native data protection tools built in, is the ability to do selective restores. And in this case, it means selectively restoring a VM or a file. And now we're starting to see Trilio Vault is providing application-specific interfaces as well, for example, MySQL. And you can see here that in this case, we're doing a selective restore to another location and showing that we can restore a VM in another region or another availability zone. We define the network for that. We select the virtual machines, select the type of VM resources that we want to be spun up where this recovery is going to land. And up top, you see it's pretty intuitive to pick the snapshot that you want to restore from, and then what you want to do with that. To selectively restore it, to mount that directly, to use it, or delete that to clean up in room. So selective restore, really important capability. Monitoring, again, nice modern, good-looking GUI here, and this is really important in data protection environments to be able to see the performance of backup jobs as they're running, to be able to track the success of the backup jobs, and of restores. And we found this to be, right up there within the, the latest modern data protection appliances. User interface is very, very straightforward, intuitive, web browsable from anywhere, responsive, all the good stuff. So next, let's dive down into a little bit about the architecture. And in this case, we did a backup of I think it was a 40 gigabyte data set. And what we wanted to show is that the architecture is scalable to meet the demands of an agile cloud environment. As your OpenStack is growing to meet the needs of the business, you need to be able to grow your data protection infrastructure and the horsepower of it, in this case, the data mover horsepower, to be able to keep up. In this case, we were showing that you get near linear performance scalability as you increase the number of data movers that are working to provide, in this case, the first full backup. We'll see later on that the incrementals are a lighter resource. This near linear scalability, there's theoretically no limit on the end to increasing the data mover performance capability here. So that's one of the potential bottlenecks in data protection, either backup or recovery performance path. And obviously where you're backing up from and to, in this case the NFS, and the infrastructure of the OpenStack source where you're backing up from and to could be another potential bottleneck that you'd have to tune, but the data mover itself, it's very easy to make sure that you're architecting so that that isn't the bottleneck. Next slide, please. So Trilio Vault is integrated with native services in OpenStack to use disk-based snapshots. This is really, really important. And it's because of this, it uses basically forever incremental technology, and actually kind of rolls in what I consider kind of like a rolling synthetic full. The Trilio Vault team might help correct me on my terminology here, but the benefit here is that after you only need to do a full backup once ever, and from then on that's incremental. And here we're showing the backup duration in seconds. The first one took about 34 minutes, and the subsequent ones took about 6 minutes on average. Next slide, please. So why does this all matter? One more. So, data protection and recoverability has been a challenge for a long time because downtime can impact productivity and revenue. If you're providing this as a service, OpenStack services to your organizations, you're trying to provide the agility and availability of a cloud-based service, either internally for your organization or as a paid-for service. So if you're working as a service provider, you need to be online and available and need to avoid downtime. And when downtime happens, you need to be able to get back up as quickly as possible. OpenStack and Trilio Vault is purpose-built and built into and leverages native OpenStack for services for backup and recovery. And ESG Lab, we validated it definitely works as advertised. It's very, very easy to deploy and configure and to manage, and that has a scalable architecture to scale meets the need business, and you can do really fast backups, and you can do really quick selective restores. So thanks a bunch. I'm going to pass off to Billy, who's going to give you a quick tour and an online demo.
Live demo, no less. Go, Billy. Love the courage.
May the demo gods be with us today. There we go.
Yes, may the demo gods be with you.
All right, we're doing a little switch control here of the screen. Can everybody see my screen? Lisa, can you see it just to make sure?
Yes, I can.
Okay. Let me just, Brian, thank you. That was a great tee up. Again, this is Billy Field with Trilio. I run the cloud architecture team here, so I have the joy and privilege to talk to everybody at meetups, at the summits, but also to hear the challenges that we're continually running into in the backup and recovery space, specifically with OpenStack. So thank you for taking the time today. I really wanted to nail down, this is a demo, but I really want to do a prelude here to kind of set the table on what Trilio is, right, and the value prop. So with the slide that you're seeing, so OpenStack, as you all know, is a series of services that are spun up, right? And what the inception of Trilio was that in order for us to grow and scale and to be cloudy, we need to fit this model, right? We need to be another pillar within OpenStack as a service, and we are the data protection as a service aspect for OpenStack clouds, okay? And to the right, how to achieve these attributes of the cloud, we got to kind of fit and conform into that, right? So we got to be downloadable, seamlessly through a portal. Just download our code and go. We can't be clunky, heavyweight agent, much like the legacy topologies, right? Because you run into many bottlenecks and challenges there. Cloud is built with the tenant in mind, right? Multi-tenancy. So we got to have those attributes as well, along with the scalability and flexibility to get the solution installed. I'd actually even throw in manageability here as well. But when you install Trilio, we have to be non-disruptive, meaning we can't reboot a bunch of your compute nodes and your control stack. We can't do any of that. We got to seamlessly slide in there. And the last thing here is, as these workloads grow and grow and grow, the nature which Brian just talked about is we do a full once, and then we got to get to that incremental daily rate of change. The industry 3 to 5% rate of change, because your backup windows, they'll shrink drastically there. You only have so many, 24 hours in a day to do stuff. So as these data sets grow and grow, we got to make sure we get that stuff backed up and protected. And then the last thing is the most crucial, right? We are OpenStack native, and Brian kind of touched a little bit about it, but we hook into every OpenStack native API call. We talk to each API endpoint. I will say I only have 10 minutes here, so please, I'll set the table here for the next slide here. So if there's something of interest to you guys, please reach out there to the right, go to trilio.io, request a demo. We can dive deeper here, talk about the knobs and buttons that we do to get things done here. Setting the table. So what does Trilio support? So which version of OpenStack? We started back in the Icehouse days of when things were trying to figure out what was going on, and we've qualified all the way through Okada. Within a couple weeks or so, we're going to be having the Pike kickoff stuff for qualification for our Q4 release. Okay, so we try to be an N-1 topology from version perspective, and every quarter we stay right to that tried and true. And then when you see what I do here in the demo, the question usually comes up is, which distributions of OpenStack do you guys support? And you see right there on the bottom left, we got most of them. We've got SUSE, Red Hat, Mirantis, Canonical, and Upstream. So as you can see, my DevOps team and test teams are heavy at work every quarter trying to get each distribution supported, tested, and check marked so that my team can go out and provide backup and recovery for whichever distribution you guys are on. Okay, so let me flip over here. Do we want to take let's see here. All right, there we go. All right, so I'm logged into my live demo here, as Lisa said, so we'll make sure this works nice and neat for you guys. So the first thing I want to kind of show you guys is we are tenant level. We're tenant driven. So when you log in here as a tenant, you'll see the compute, network, and object store buckets there. But what you'll notice here at the very bottom is we expose a backups tab, right? So we have our own Horizon plugin that seamlessly gives you all the interactions and the functionality of Trilio built within a UI metric here. We also expose a REST API and CLI for service providers that like to make specific calls to us to get specific metrics. You can do that as well. But when I go down to the backups tab here, like Brian talked a little bit about, is you can start categorizing, again, in the tenant space, you can start categorizing and building service level agreements for your workloads. And what that means is I can start saying, I've got workloads that are at platinum, a gold, a silver, and then what I can do is logically bind those to an RPO, RTO. Okay, so if you look there, I've got a platinum, silver, and gold. It's a 2-hour, 8-hour, and 24-hour RPO respectively. And if I dive into the workload, one thing that Trilio does really seamlessly and really nice is we get not just the data as a part of our backup, right? Not just a volume and not just a file system, right? Because again, we would be legacy at that point. That's just not cloud, right? That's not how we want to do things. What we do is, again, tap in each service API. I can now get all the metadata about that cloud at that point in time to capture it, okay? So we'll talk to Nova, we'll talk to Neutron, we'll talk to Cinder, we'll talk to Keystone. We'll do all that under the covers, and the reason why we do that is if I look at this workload that has a 3 VM workload set defined, if I click on the snapshots, these are my incremental points in time that I've captured from that workload, from those 3 VMs, okay? So if I dive into my latest incremental capture, what you'll see here is the information about the backup, okay, size, how long it took, et cetera, et cetera. And then I'll see here in a tabbed form here, I can go through each one of these VMs, and what you'll see is I grab the IP address associated with the VM. I grab which network it's a part of. I get if there's scripts registered within the QEMU guest agent. But additionally, I get the instance information. I get the security groups that the VMs are a part of. I get the flavor, the make and model of the VM from a compute, disk, and RAM standpoint. I get which network that is tied to. And I get the volume types and volume configurations, okay? So what you'll see here is when I capture this information, in addition to the data, what I've effectively exposed to my tenant is the exact point in time, much like Mac Time Machine for your cloud, for the tenant, okay? And not to really kind of keep, Brian's done a great job, but if I come back here, backup is kind of the necessary evil, but what I want to expose is getting all that metadata. Now what I can do is I can flip it on the tenant. Now I can expose from the tenant point of view. I can recover or interact with that data, okay? So we expose a few different operations of restoration. The first one I'm hovering over is called one-click restore. And the definition of that is if those 3 VMs that are a part of that workload have been deleted, if they've been corrupt, whatever it might be, one-click restore takes that exact point in time, metadata and data, and it restores back into production where it came from, the exact look and feel of that cloud. Volumes, network, IP addresses, availability zones, et cetera, et cetera, et cetera. We're putting it right back where we got it. Okay, we took that that functionality a little bit. Okay, maybe I don't want to touch the VMs per se. Maybe with an in-place restore, what I've exposed now is maybe the VMs are in a good state, but I've got some device issues, right? My hard disk or virtual disk stuff is it's just not readable. Something happened. My application went a little wonky there. So in-place restore allows me to go ahead and define, so if I click on one-click, I can take each one of these VMs, and I can say restore the VM or restore just the boot disk. I can say restore the VM, restore the boot disk, or restore the Cinder volume associated with it. So these are all multi-select, so I can deselect and select, include or exclude whichever component I want. And again, this kind of gets you per VM, per volume that I can restore just one element of that virtual machine or virtual machines. Okay. And then, like Brian did a great job of explaining this. The next option is a selective restore. Maybe what I don't want to do. Maybe I don't want to interact with the source data at all. Right. I don't want to touch the. I want to take my workload and I want to push it to a different region or a different availability zone. Right. More importantly, when I do that, different availability zones, different resources per se, I can then go ahead and say, hey, put those VMs on an entire different network, okay? All 3 VMs on a different network. I can go ahead, if I have different volume structures, LVM, iSCSI, Ceph, you name it, I can tie it to different volume structures. So if it's LVM, I can make it Ceph, or Ceph, I can make it LVM. And then for each VM instance, the nice thing here is I can, number 1, rename the VM, right? We'll show you the source. Number 2, I can reflavor it. Again, disparate resources, potentially in different regions or different locations. So I can make a large, a tiny, a large, whatever it may be. And then I can put the instance in a different availability zone. So I click on here, I can go to availability zone number 2 or Nova, pick or choose. Now the nice thing about that is I can do that per VM. And as you'll see here is you can even do the volume structure. So I can put my VMs in availability zone number 2, put my test valve here into a different zone as well. And the nice thing about it is you can start to basically build this point in time of this cloud and reconstruct it and put it somewhere else. Use cases are test and development, Patch Tuesday for Microsoft. Maybe I don't want to test my application and all these updates in prod. I can respin the entire, the entire cloud into a different region and then basically test those the patches there as well. So you start getting into a little bit, maybe some compliance, a little bit of a surety that the security is there, everything's going to work well with your applications. Okay. And then the last thing here is maybe I don't even want to interact with the VM at all. Okay, maybe I just want to do a logical mount of the volume structures associated with the VMs, and then retrieve a file or a folder. So Trilio offers up this mount snapshot functionality. And what we do is we will actually ship a Ubuntu-based VM that you'll mount these volume structures to. We expose a web interface or a CLI interface that you can go ahead. The mount snapshot takes roughly 30 seconds, as much as the time as it takes to present the disk and rescan the adapters. And then the tenant can then go ahead and search their files, grab whatever they want, download it locally, SCP, SSHFS, whatever the tenant needs to do to get that data from that point in time, extract that. Okay, so when you start thinking about recovery here, backup's one thing, but where the value to Trilio is from the restoration. The legacy approach, one thing I'll say here is some people are good at just volume structure stuff. Some people are good at scripting file system stuff, but you cannot guarantee an exact point in time with the exact flavor, the network configuration, the volume type to restore the entire tenant space, and that's Trilio's bread and butter. That's exactly what we do. The last thing I'll show you here is we've expanded the mount operations, so we've exposed a nice workload search here. So I can search for file structures within my workload. I can go ahead here and select whichever VM I'm curious of. What I do by default is I can filter on all the snapshots, so this will give me every point in time that I've run as a part of the workload. I can go ahead, I can do a date range, start and end date, so I can say only show the points in time of the last 2 days, 5 days, 5 weeks, whatever it is. And then lastly, I can go ahead and just filter out those snaps based on a quantifiable number of snapshots. Okay. So once I select that, let's just show you live. Here's the demo guys here. So I'll just search for Etsy Star here, and what it will do is it'll show me. I only picked one finite resource, one snapshot, but what we're going to do under the covers, if you had 100 listed, we're going to do a real live. We don't index everything because of how we store the data in native QCAT2 format. But what I'm going to do is I'm going to show you the search result in every single point in time that I've captured. So here's the point in time at 1:15 that I searched. We searched. We gave you everything with Etsy Star. Okay. The next release, we're going to actually have a recover window here that'll actually do the recovery as well. But this at least gets you the snapshot ID where it is, and you can go ahead and restore that. Okay. So that's from the tenant space. Again, Trilio.io, request a demo. We can go into architecture. We can go into how we do what we do. But last thing I want to show you here is if you put your hat from a tenant space into the admin space, we expose the same at the very bottom here. We expose a new tab here called Backup Admin. And then what we do here is from the administrator point of view, I can get a holistic view of the cloud. So if I have one tenant or I have 1,000 tenants, I can see holistically what's going on within my cloud. I can see all the workloads here. I can see which availability zone, what the name is, what their performance are, what's passing, what's failing. I can tell you per tenant, per workload, how much storage they're using, where it's writing data to, okay? Another nice thing that we can do is we provide configuration backup. So if I come over here to live demo, there we go. My team's rebuilding right now, but effectively what we can do, OpenStack, the community has a nice knowledge base article of all the services and file systems and MySQL databases to back up per component of OpenStack. Trilio backs that up as well. Okay, so if you're looking for configuration backup within OpenStack, we do that. Here's our Trilio Vault VMs, our lightweight data movers here. Again, Brian did a great job. So we have a lightweight Python-based module that sits idle inside each compute node. And then when each job is running, it wakes up and does the operation. So in this case, I have two. We give you the global storage used, consumed. We have an onboard audit system. We have your mail home if you want to do SMTP, and then our licensing here. So I'm kind of pushing the edge here on time. I'm getting pinged here to wrap it up. That, in the essence, if there's any questions, Tom, Lisa, maybe we can jump into that. I'm sure there's probably a few, but I want to give enough time to answer some questions and answer before we run out of time here.
Okay, thanks, Billy. Gosh, that Vault dashboard was actually pretty cool. I like that. Well done. Did you guys build something on top of Horizon, or is that just straight from OpenStack?
Yeah, so it's just our own API calls into Horizon. Yep. So
well done.
The thought process was why give why put another management tool in front of the user when we don't need to.
Exactly. And good job with the demo. It must have been the demo goddess that was looking after you. Well done. Thank you very much for that. Okay, so we're going to open it up to Q&A. I think there's places you guys can type questions in if you have them. I actually have a question for Brian because I understand that you test a lot of data protection products each year and or projects, and so I was just kind of curious if you could talk about the kinds of data protection products that you like to look at and what that process looks like.
That's great. We've been doing this now for more than a dozen years, and we do anywhere between 10 and 20 products a year, and so that's everything from the majors, the Veritas Net Backup, IBM Nail Spectrum Protect, Commvault, and to startups and emerging companies like Trilio Vault and Veeam. I mentioned we do a lot of work with Veeam as well. So this is actually a place where we have a really strong heritage and a reputation of understanding, being able to communicate, and see whether stuff works as advertised. So we've tested just about everything, and we kind of stay current and have seen the latest and greatest. And what we're seeing here in Trilio Vault, that really is, it's the new trend, is native services, getting rid of APIs, modern RESTful GUIs, RESTful API controls so you can integrate and monitor. All the best of the new stuff is what we're seeing in Trilio Vault.
Okay, very cool. And Billy, if you can also talk a little bit about, I saw that you talked about the distros that you have out there, but how about the OpenStack cycle that you're on? I understand you guys are on Okada, is that right?
Yeah, it is, yep.
Okay, so yeah, maybe you can talk a little bit about how the upgrade cycles work. I think that might be interesting for people who go through it as well.
Yeah, that's a hot word, right? So I really put pressure on my team. I really want to stay cutting edge on features and functionality, number one, but I want to be up to date on, as tight as we can to the release cycle from OpenStack, right? So, with the release cycle of the community, I kind of put the team on a quarterly release cycle. Okay, so at the end of every quarter, you will get new code from Trilio that supports. It could be anything from just features, or it can be the latest release of OpenStack. For example, it'll be Pike for the next quarter, for example, right? So, so that's from a DevOps perspective. We take from the spear down. Hopefully, we're going to be max time out of sync is probably 6 weeks of a release. Okay. From an upgrade perspective within Trilio, again, to make things really easy, the Trilio Vault virtual appliance is built from the ground up as a stateless VM. Okay, we store all our metadata, our internal database, all our configurations onto the repository, and our upgrade path is just as easy as launching a new Trilio with the new internal code core components, and then just import the metadata. That's really all it takes. So the upgrade cycle with Trilio takes roughly 5 minutes or so.
Wow. Okay, impressive. Okay, so I actually don't see the question panel on my screen. I don't know if Tom or Caitlin or anybody else who can see the dashboard wants to read out a question. Oh yeah, Caitlin, why don't you read out if you see any questions.
I have a question for Brian. Just curious to know, what was the RPO or RTO for your lab validation, and was the workloads rate? Or what was the workloads rate?
So the RTO, we were testing with a variety. We saw the gold, silver, platinum. So we tested with minutes, hour, and day. So we tested different RPOs. Recovery time objectives were on minutes for selective restores. I don't have the information for what it took to spin up when we did the remote recovery, but it was minutes. It was relatively quickly, but it needs to restore that up. I think I answered the first part. I'm not sure what the second part of the question was.
The second part was what was the workloads rate?
I'm not quite sure I understand what that question is.
Okay, no worries. We can follow up with them after the call. I have two questions here for Billy. When you restore a single file, do you need to restore the whole VM image? And secondly, are the vault backups encrypted?
Great questions. No, the file restore has nothing to do with the VM, so absolutely not. So that is literally just the file that we can grab from the backup image. Again, whoever asked that, we can take that out. I'll show you exactly how it works. And then the second question was, are backups encrypted? They can be. We really want to leverage the technology that is around us, right? So we support everything from Swift to NFS, working on Ceph-based target today. So the repository, the backups can be either encrypted at the target repository if the tenant or the admin chooses to do so. So it's up to the team.
Great. And one more question here for Billy. There's a project called Raksha for backup. Does the Trilio follow that or set a separate standard? Those two words are synonymous. So our CTO and co-founder, I think 4 years ago, actually wrote that technical specification for the community. So Project Raksha is Trilio. So that's it gives us a nice 4-year head start on this initiative, which is a good thing. But yeah, the Raksha is Trilio as a corporation. Great. For Billy, can we have the architecture and how this can be implemented in OpenStack in customized environments?
Yes, I can. How much time do we have? If you want, I can share a slide. Let's see here.
We'll follow up individually with this question, but thank you.
Okay. But the last thing I'll say, I can verbally add to it. So Trilio, just to give a little context for people listening today or whenever they decide to wrap up on this. So Trilio ships a virtual appliance in a QCOW2 format, and it'll sit on top of a KVM box. Okay. We install and register a API endpoint at the control plane, and then the only thing that's required beyond that is a lightweight Python data mover that sits on each one of the compute nodes. These can be installed manually through some sort of local scripting or just /run it, or we can provide you with playbook scripts with an Ansible, or we've actually had some requests for Chef, so we can provide the scripts that you can plug into your Ansible playbooks to deploy it seamlessly within your DevOps play for your cloud. So we can work with the team on that as well.
Great. And the performance window you showed, what kind of performance are you monitoring? Disk I/O or others?
Is that for Brian or for Billy? Sorry, I didn't.
Yeah, well, I think it's probably a Billy question. We were showing throughput elapsed time for backups to show the incremental, but I think maybe the question might be, Billy, you showed some monitoring and the performance monitoring graphs, and yep. So what are we showing there? And I think the answer is a little bit of all the above, right?
Yeah, so we monitor our jobs based on runtime and data rate of change, right? So the lines you saw were a runtime of the job plus how much data moved, and then we kind of correlate those numbers. So, we don't do any like iometer or back-end disk utilities that go ahead and say, yeah, there's disk thrashing and you got this for hotspots. We're just monitoring how fast we write the data and how much data we're writing or restoring, excuse me.
Okay, if that's the last question, Caitlin, are there any more queued up?
Yes, I have one more. For you, Billy, can you talk about how you can architect performance around Trilio?
Yeah, it's the benchmark that we set it's actually really simple, right? Because coming back from my background days of EMC, and we have had big tool teams and performance teams. The Trilio architecture is our baseline performance metric is really simple. It's how fast you can write a file with a CP command. So if you do a Linux-based CP, if you move a file from source to destination, that's our transmission rate. Because the reason why I say that is architecturally there's infrastructure that's faster or slower and network bottlenecks and things that are not directly tied to us as a product. But our benchmark is how fast the CP runs, plus or minus how fast we can get the metadata, which is measured in a matter of 1 or 2 minutes. So CP command plus the operations of metadata transfer and reconstruction.
Okay, thank you very much, Billy. And thank you so much, Caitlin, for jumping in and helping us with our technical difficulties. Really, really appreciate your help there. And I really want to thank the team here this morning. You guys have been listening to Brian Garrett, who's the Vice President at ESG Lab, and Billy Field, who is the Director of the Cloud Architecture for Trilio. And I am Lisa Marie Namphy from the San Francisco Bay Area OpenStack User Group and OpenStack Ambassador for the U.S. And we really appreciate you joining our online meetup this morning. It was a lot of fun. Thanks so much, guys, and thanks everyone. And if you've missed any part of this, there will be a recording posted at some point somewhere. So coming to, at an internet near you, you can find it later if you want to review any of this. You also know where to contact teams at Trilio or at ESG Lab if you have any further questions for any of us. Thank you so much and have a great day.
Thanks, Lisa. Thanks, Brian. Thanks, everyone.
Thanks, everyone. Bye.
Bye.